Hey guys, welcome. Yeah, so first and foremost, praise the Lord Jesus Christ, because he keeps knocking Satan the fuck out, even though Satan is a retard, so never learns, but it's fun to watch Satan get punched over and over, so I'll enjoy the show. And second is, I came across this integral while I was preparing more lessons for complex analysis, and this integral was to be done using contour integration. And so I will dedicate a later video to showing you how to do this using contour integration, but as an appetizer we can do this on partial fraction decomposition with just partial fraction. So let me show you how to do that. Okay. All right. So you know, partial frac, so we focus on the quotient 1 over the product of those two binomials, and so we want to split that into two quotients, right? That's the goal. So we go like, all right, so let's say that 1 over x plus a times x plus b is equal to, u over x plus a plus v over x plus b, where u and v are constants, right? And you know, the algebra that we're about to do is about figuring out what constants u and v are, and to that end what we should do is have common denominators on the right hand side, and that way we could just set the numerators equal, right? Okay, so that means that next we write 1 over x plus a times x plus b equals, just wanted to like catch my breath, just kidding. Okay, this is equal to u times x plus b plus v times x plus a over x plus a times x plus b, right? Okay, and of course what follows next is that we require, since the denominators are the same, that the numerators be the same. So that's to say that we want one numerator here to equal the numerator on the right hand side. So 1 equals u times x plus b plus v times x plus a. And the most efficient way to move forward here is to make specific choices of x that simplify this equation, because this equation has to hold true for all x's. So like a good choice of x is like x equals negative a, because then that will annihilate this and would allow us to solve for u. Specifically, when x equals negative a, this equation is going to turn into 1 is equal to u times b minus a plus 0, so that, and so then u is equal to 1 over b minus a. So this is 1 over b minus a. Got it. And using another great choice of x, this time negative b, we're going to get the equation 1 is equal to, well, 0 in this part, right? Plus v times negative b plus a, that's v times a minus b. And of course from here we can see that v is equal to a minus b. Got it. Well, sorry, 1 over a minus b. V is equal to 1 over a minus b. All right, so then we're good. This is all that we needed. Because now we can say that doing this integral is the same as doing this integral, which we can, if we so chose, turn into two integrals. Right? Okay, so this here equals the sum of them, and the first one, right, we could write as 1 over b minus a times integral, and of course we should throw on limits 0 to infinity. All right, I guess I'm being a little casual, like, because I should express this integral 0 to infinity as like limit as y goes to infinity of 0 to y. So like just important details, but I'm not doing it because I'm approaching this a bit casually. Okay, so 1 over b minus a, and then 0 to infinity, and then it's going to be what? 1 over x plus a, right? Okay, and then plus, right? And then now it's going to be 1 over a minus b times integral 0 to infinity, and then 1 over x plus b dx, right? Okay, so in this part we get, well, it is here that I'll use like the limit notation. So lim is y goes to infinity on both integrals, right? Okay, and so then we're going to get 1 over b minus a, and then natural log of x plus a, right? And then plus 1 over a minus b, and then natural log of, well, they're both going to be evaluated from 0 to y, and then y goes to infinity, but natural log of x plus b. And now I want to do, before I throw on the evaluation, I want to do one thing, which is like to synchronize these. Like, let's write that a minus b is the same as b minus a, but with a minus sign right here, right? Okay, so lim as y goes to infinity, right? And what else did we forget here? Evaluate all this 0 to y. And so that amounts to plugging in y first and then plugging in 0, right? Okay, so, and then taking the difference, obviously. So if we plug in y first, and we'll do the difference right here, and then plugging in 0 will come. But yeah, if we plug in y first, that's for x that we plug in a y. So it just makes this a y and this a y. And when we plug in 0, right, we get 1 over b minus a, which now we can factor out, right? Like, so we could factor out 1 over b minus a, and so we could just have this, and perhaps I didn't need to go all the way there then. Okay, so yeah, in this part what we need to do is plug in 0 into this, so we're going to get 1 over b minus a, and this minus sign though is from the evaluation theorem, right? 1 over b minus a times the natural log of what? Well, this was an x and this was an x, they're going to become 0 because that's that part now. So natural log of a minus natural log of b, right? Like that. Okay, now, so this here we can condense a little bit using log rules, right? So it's going to be the natural log of y plus a over y plus b. I have lots of videos on log rules, so yeah. So in here, it's just going to be one giant natural log of y plus a over y plus b. I have lots of videos, if I didn't just say that, on log, so check them out. Okay, now clearly as y goes to infinity, this here is unaffected because, well, yeah, like there's no y here. Okay, but in this part, as y goes to infinity, first we can use limit rules to put this limit right here, natural log of, and lim is y goes to infinity. But yeah, you should know from pre-calculus that, like, you know, x plus a constant, like over x plus another constant, as x goes to infinity goes to 1, right? Okay, and so then similar situation here. So this is going to go to 1, this limit. So we're going to get the natural log of 1, which is nada. So this whole thing is blank, right? Okay. And this minus sign, right? We can now like kind of like, go in the reverse direction of where we're at. And yeah, so this be your final answer. And what is it? So when we get to doing this integral using contour integration, you should keep me honest and check that the answer is this. Now, can we simplify this a little bit more? Well, if we had a little bit more information, like if we knew the size of a and b, right? So is a greater than b or is b greater than a? Because if b is greater than a, right? If we had this, if b is greater than a, this here is a negative number, and so we'd first combine the logs and use it as an exponent, but a negative exponent, we'd apply negative exponents and all that. But you know that, and yeah. Keep watching. Take care.